Thank you so much. Good afternoon. It's very nice to be here. The presentation is about the AIM-eBIM project, Built Heritage Adapted Information Management through Artificial Intelligence. The project is a regional project funded by the Emilia-Romagna region under the program European Regional Development Fund. And the main focus of this project is the finalization of digital data from integrated survey towards adaptive BIM modeling. So by means of digital model segmentation procedure, the data is, let's say, decomposed in different components and different features in order to create an information population of the BIM model adapted to the needs of managing intervention on the existing building, because the main focus, of course, is how to manage all the requirements for refurbishment and for conservation of existing heritage building. Of course, in order to decompose the information and to segment and classify digital data, application of AI are under exploration, and the main focus is how to find thematic criteria in order to manage this main purpose. Here you can see the partners of the projects. Research labs are the one you can see listed here. The project is coordinated by the TechneHub laboratory by the University of Ferrara. And you can see that we have 4 laboratory of research partners from Parma, from Bologna, from Modena and Reggio Emilia, and the Centro Ceramico, that is a consortium for the management of the research and experimentation for ceramic industry. Of course, this kind of funding by Emilia-Romagna region are focused on industrial research. So we have a component of research action and practical outcomes from an industry point of view. So also companies are involved in the process. You can see the companies that are working with us in order to reach the main outcomes. It's interesting to understand that the companies are essential in order to understand the main requirements from the side of the construction sector, and different companies are involved in order to cover the main areas under analysis, so digitization, but also the construction site. And the management of software and tools in order to reach this focus. In a nutshell, the concept of the project is the one that you can see in this schema. And the main aim is to find actions, to find a workflow to reorganize this large amount of data according to thematic criteria that are consistent with building information modeling requirements for existing heritage. So the schematization is focusing on this point. So how to work in the direction of creating effective procedures, let's say from a practical point of view for the construction sector. 4 main steps are under development. The project is in its first year of development. The first action is focused on the data capturing, because we can't conceive any workflow for data management without considering how to improve possibly data capturing. The second section of the work is related to the criteria for performing segmentation. It's interesting to highlight that we divided the criteria for thematization into 3 main groups that are material and components, morphologies and structures, and all the conservative aspects. The third step is related to the enrichment of BIM modeling through this thematic population according to specific thematic tests. And of course, these tests are performed according to these categories. And the last step is related to the search for current opportunities for data sharing in order to analyze what kind of new open collaborative platforms are usable in order to reach an additional main goal, that is the interoperability and the spread of project results within main stakeholders. As the background of the project, I'd like to mention that another project were funded within the previous program, original program. The project was called eBIM. Now we call the project AIM-eBIM. Also to stress, to highlight that the state of the art is improving very, very quickly. So within the eBIM project, some very relevant shortcomings in the workflow were faced. One is related to the platform for data management, as you can see in this screenshot. But of course, even if the topic is very well explored nowadays, some challenges are still in need to be covered, and the optimization of digitization is one, even if the tools and procedure are let's say, very solid nowadays, but the quick changing in devices needs to be understood very deeply in order to understand what kind of data we can obtain today with new tools. Of course, data thematization and segmentation is a process that it's improving very, very deeply. We were in need to test new parametric modeling processes in the optical of adaptive thematic population, and of course adaptive is a key word of the project. Also thanks to simulations on BIM models with thematic data integration. Other section of the state of the art to be improved, to be faced somehow, are related to the BIM-oriented material sheets in building products. I mentioned before the Centro Ceramico is one of the partner of the project. They are in charge to understand this connection among the industry and the way in which this BIM modeling improvements and these new tools are effectively used by professionals and industries, and very often these kind of tools are not exploited. And of course, the analysis of new tools for sharing adaptively populated digital models. The state of the art includes also all the improvements in BIM modeling. Here you can see just some example of models performed by our research group. Considering the needs for existing heritage and the needs for historical heritage that are somehow different for the complexity of data to be integrated. So the state of the art in this direction covers technical aspects, but also all the improvements in the management of this kind of complexity that we can see nowadays. So the main advancement beyond the state of the art as related to to digital surveying technologies, because we have more and more great amount of data, often unused or untargeted for purposes of intervention on heritage, because they are difficult to be discretized according to specific features and characteristics, and also due to issues of practical utility, and sometimes are difficult to be integrated. I would like to stress for this point that maybe we should consider the research field and the professional or industrial field that sometimes cannot match. Companies and professionals very often are not keen on applying BIM modeling, and so infrequently are able to adopt efficient data sharing systems. And AI, of course, is at the forefront of the evolution of the process of improvements, and this rapid innovation needs to create additional integration within the construction sector in order to be more efficient. We are working on some thematic tests Here you can see the first one, that it's an historical complex. We are in Verrucchio, near Rimini, with the museum and the fortress. The choice of historical buildings, of course, is to cover the need for thematic understanding of criteria for conservation purposes. But we are also working on 20th century building. Here you can see the former Colonia Varese in Milano Marittima that is under analysis. Of course, it's a very, very different kind of building with different requirements from the side of understanding, modeling, and of course requirements for intervention. Just some screenshot of preliminary digital data processing and assessment that we are doing now. Additional thematic tests are related to reinforced concrete structure and masonry building. This part of the research is covered by University of Bologna, covering the part of the needs to understand how to apply this thematic adaptive population to the needs for structural improvement. So 2 case studies have been selected also for these purposes. And in addition and in parallel, in working in modeling geometrically these case studies, of course we are working on the algorithmic procedures, testing the first section of the work on the Verrucchio Museum, so that on the historical building that is the most complex to be faced. Selecting the data set to be segmented and classified by using also point clouds and photographic data set. The segmentation is according to materials and techniques. And this part of work, of course, started with the assessment of the incidence of the different features in classification. So very shortly, the procedure that is very well known, let's say, is the definition of an abacus of classes to be segmented. It's interesting to highlight that the procedure of identifying classes is the focus of the work, of course, and in this step stays the interpretation issues. We extracted geometric features with 3 different ranges, and we went on with the manual segmentation to annotate the part of the data set for algorithmic training. Here you can see some screenshot of this process of selecting the main features needed to work for algorithmic training. Then we tested two procedures, two algorithms. One is a random forest, with the procedure of splitting annotated data set according to training and testing for the prediction of the classes, and working with an additional algorithm that is KNN. We performed also a cross-validation matrix, this grid that you can see here, in order to understand the perform parameters optimization. Here you can see a zoom in of this matrix. And of course, the feature importance graph was extracted also to assess the weight of each feature in the algorithmic prediction. So these procedures are, of course, still in progress, are really interesting, understanding on different data sets what is happening in terms of calculation of the algorithm, and in terms of prediction of what is possible to use for the feature extraction. And in parallel, we are working on the BIM modeling, of course, of the same case study. We are in Verrucchio once again, and starting with the connection among the point cloud and the BIM environment. After visual analysis, but also additional assessment and the searching for other informational source, we work for organizing the components according to specific nomenclatures, so category, function, and a lot of other specifications. Also placing textual descriptions. And since the main purpose is to query the model to extract crucial information, we are thinking about 3 main solutions to organize this, let's say, connection among AI predictions and the features to be placed in the BIM models. So by filling in materials parameters, application of keynotes for specific features, or the application of design parameters. Of course, the main point is the scope of the model. If the model is set up for project purposes, the work will go in one direction. If the purpose is to perform a specialist analytical model, the workflow can be another. So we are now at the moment of processing these different actions in order to find the focus of the project, that is the connection among the algorithmic thematization and the BIM processing. I'm going to conclude just highlighting 2 points that, of course, experimentation are needed because in this project that merged together different state-of-the-art processes, the most important focus will be the connection among these steps, of course. And we are putting a strong effort in analyzing data capturing requirements. So the step 1 of the research, because the way in which data are captured influenced, of course, the way in which data are managed by the algorithm, but also for thematic assessment and for interpretation of features. And of course, the how segmentation can really support the management of specific parameters is the key question that we hope to let's say to improve in the next steps of the project. Thank you so much for your attention.